下载的就好，不用 join audio，也不用 share screen，对吧？
Hi, sorry about the late, guys. There was one or maybe two accidents on 5, so delayed me another 10 minutes. Sorry about that. Okay, so is everybody here? I know some of you guys may be AFK right now. Just gave another 30 seconds or 30 seconds or so everybody can get ready to start. Any questions so far about last week's recording or homework 3? You guys can all hear me, right? Okay then. Yeah, no problem. Just be aware of the deadline. I forgot which day exactly is the last day to submit it, but just watch out and submit on time. Okay. Yeah, that's should be a very simple one for quick modeling, and maybe next week when we have time, you want me to go over that, just model it really quick. I can do that. So let's talk about today's stuff, because today I'm gonna show you guys how if I were a student and how I'm gonna complete the first project. Yes, the last recording, I think I posted on Saturday or maybe Sunday. I apologize for a little bit late because I thought I posted on Friday, but apparently I didn't. So I think on Saturday or Sunday I caught it and I uploaded it. Yeah. All right, let's open up. Okay, this is the part. So everybody's staying right now? Yeah, because what I'm about to show you is what I expect from the project 1. So pay attention in this lecture. That'll help you to complete your project 1, and which is 30% of your grade. And pretty much you do, you follow my technique on drawings and you'll be fine. So first thing, this is a model that I'm gonna draw. I'm not gonna show you how to make this model right now. If we have time after the drawing, we can do that. We can go over it. But this is very simple. It's just one revolve to make the body, and then few cut extrude to make the windows and holes. This is a hole. This is a simple hole, and this another cut extrude to make some features, and then this is a hole wizard to make one hole and another hole. So pretty much this is, I call it a driver support. So normally you're gonna see this type of thing on like any vertical rotating equipment, something like that. The purpose of it is to have a motor sit on top. So that's where the flatness is gonna kick in, because this surface, you wanna have like certain degree of flatness. So the motor gonna sit on top, have no problem. And then this, if you look at the top view, this circle and this circle, oh, so hard to highlight. All right. Sorry, this circle and this circle should be concentric, because the electric motor gonna have a vertical shaft, gonna stick down and gonna go through this hole, go through this big hole first, and then go through this little hole first. Normally, we're gonna have a certain type of seal, like a seal housing or something, sit right here. But I just want to make the case simple. So this shaft gonna stick down right through it, and that's where the total run out gonna take place. And apparently we have, look at this is cosmetic thread hole, and those are just through holes. So for the thread hole, we're gonna, for both holes, actually, we're gonna have position to regulate those holes' position. And these, and there's another one right at the back. So two flat surface, these are for the sensors. So for the rotating equipment, sometimes we want a sensor to monitor the vibration, because when the stuff is about to explode or is definitely acting up, the vibration gonna tell us everything. So these two places are for the sensor. That's why I have a flat surface. If you can see, the top plate is all round, other than these two spots. These two spots are flat and has a little hole right here just to place the sensor. So this hole can be threaded or not, depends on what type of sensor you use. Sometimes the sensor can just be glued on there. If you don't, if you have no need to reposition it, you can just glue it. So pretty much this is about this driver support, or whatever support you call it. And these two windows, so either is for visual or is for installation, because sometimes you drop the motor on the top and you're going to have some tool to guide the shaft, or you're going to have a coupling system to connect two line shafts to the motor, right? Because the motor shaft is relatively short. Everybody who worked with electrical motor before, you know, like the motor stick down is only like few inches. So in order to connect with the motor, you're gonna have another shaft stick up here and have a coupling assembly that connecting two shafts together. So pretty much the window to give you room to operate, to do the installation and to guide the shaft, all the stuff. And the smaller window is either for reduced material or is for visual to monitor the coupling. Because sometimes if the coupling failed, either the vibration sensor will tell you, because it definitely is not under a normal condition. Sometimes it had to be visually inspected to see, oh, this coupling is failing because it's definitely not rotating in, I'll say, in a static direction or something. So that's about this part. Any question before we get into the drawing? Anything? So I assume everybody understand how this part gonna function and how this part to be installed in the entire assembly. Yeah, because if you don't understand certain part, later on the Gd&T gonna confuse you a little bit, because you're gonna ask why this surface gonna need a flatness, not this surface, stuff like that. Well, no question. Alrighty, guys. You guys just had a holiday, right? This Monday was like a Columbia Day or something. No, really? School didn't have that day off? Because I saw on like Amazon or something, they're saying like the previous week was the last weekend was a long weekend. Oh, okay. That's so bad. Government has so many vacations. I mean, we didn't take off. I was still working yesterday, so totally feel you. Anyway, so let's go to drawing. So I made the drawing yesterday, but I'm gonna make it again from scratch. So I'll give you guys a better idea how to make the drawing like this. So this drawing is kind of sketchy. I'm sorry about it. It's not as detailed as it should be, but actually this is gonna be my expectation for project 1. So I think this can work as well. So from here, the first thing to look at is 2 datums. So pretty much datum B is actually gonna be this edge. So datum B, think about it as a vertical axis, and datum A is gonna be the center axis. So the center axis can either be horizontal or vertical in this view, but datum B can only be vertical in this view. So these are the two datums I created for the Gd&T stuff. And you can see from the position Gd&T symbol, I didn't use 3 references because 2 references are, I'll say, good enough, at least for the current level. There are not necessarily to use 3 references, so pretty much it's optional. Pretty much the position only requires 2 or more reference datums. So 3 is optional. And we have a circularity right here, doesn't reference anything because we just need this outside diameter to be as circular as it could be, and the flatness right here, and total ran out through this hole. Even though this hole, like in industry, this hole won't have a shaft go directly contact with this hole, but you know, we just make the assumption in this case, so we can definitely use this total indicator right now as a example. And also those magnitudes, I just grabbed from those from the chart I showed you guys last time. Yeah, pretty much I just use a default number grabbed from this this chart, because I was thinking, I mentioned last time saying like we should do a little bit of calculation about the hole sizing and all those kind of stuff, but it's really hard to validate it. And you know, everybody gonna have different calculations, and to reduce the mistake I'm gonna make during grading, so let's just use default value. As long as it was placed in appropriate surface or appropriate dimension. So is that okay with you guys? All right, I guess it's okay. So let's make things short. Let's start making this drawing, I guess. Yes, please just use a default magnitude. Because I know in some cases it's not appropriate, but right. Actually, the hole size has nothing to do with this value right here. This is the hole's position. Yeah. So actually, what you're stating right here is right. No matter how big or small the hole is, you can always use this magnitude. This magnitude only care about the hole position. Yeah, but please just use the default value. As long as you know, like this Gd&T is supposed to be in this place, and then later on when you're doing dealing with design, you will figure out how the calculation is. It just, everybody gonna have his own calculation, so different. So when I was grading, when I'm gonna grade, I don't want to make mistakes, so you know, misunderstood something and duck your points. So let's stick with the default values, I'll say. All right. All right, so here, make the new drawing like we have done before and choose a template. So watch out the width and height right here, because this matters when you print out this the drawing. So let's choose A3 because this is actually the B size in industry. So is twice as big as A4 size, like the print size, the letter size, I'll say. The letter size is 8 by 11.5, and this one is 16 by 11.5. Okay, I'll move it right here. Any questions, just stop me anytime, and maybe we can do it again or something like that. So we have a totally blank paper, and this drawing number is default as the name that you saved your part. A model view. Okay, double click on that, and here you drop something. Okay, so from here, you click that and opens up the property manager, and let's do this one, the hidden line visible. So you can see all the hidden lines about the holes and all the stuff. And let's use customize scale because this looks a little bit small. And you play with it to get a size that you feel is big enough. This one apparently too big. Do a 0.5. It looks okay. Or let's do 3. Okay. So you can place it right here. And we gotta make more views. Definitely projection. Project view. And here. You can drop this one right here. And these two are linked together because they're referencing each other, right? So you want to break the link, you right click on this drawing, and there's a line. Oh, did I do? Okay, break alignment. So once you break that alignment, this one can move freely. So it's no longer necessarily linked together. And these center lines, you can keep those because we have this part as a symmetrical part, and all those machined circles, no matter holes or openings, as long as machined circles, we better have a cross it. So that's easier for us to do the dimensioning. All right, and here, and let's bring up a small isometric view right here just to show an example. So this isometric view, we don't have to use the hidden line visible because it looks so detailed. And let's make this really small. Oh, the other way. Yeah, because this is just a reference. We won't dimension on this one. So let's bring this to the corner. And what are the other view we have before? Okay, we have a cross-section view right here. Oh, by the way, before I make that, the cross-section, you can make it from here. This button right here says cross-sectional view, and you click it, and well, this is already pre-selected by me, but if you don't have anything, for example, you never create a cross-sectional view on this part, so pick a plane that you want to be cut in this plane. Sorry, pick a plane that you want the model cut by this plane. For example, the front plane looks pretty good. They're gonna break in half through these two small windows, so you can show the big window. And the right plane just gonna be the opposite, so it's gonna cut through the big window and show you two small windows. And the top plane apparently is not gonna form any cross-sectional drawing. And you can create the plane anytime and by any position that how you want to cut this model. We're gonna pick the right plane because we can also show the detail of these two little holes and the flat area right here. If you pick the front plane, then you're gonna deal with those later by creating, another plane and then creating another partial view or something. So that's why I create this cross-sectional view by the right plane, and then just click that and say yes, and here we go. So you can see this one is cut by half, and let's go back to here. Okay. Look a little bit different, huh? Yeah, this one has hatches, but this one doesn't have. The hatches are the shade of the cross section, and this one doesn't really have it. Let's delete it. Just key the delete on the keyboard, and yes. And you do a section. Sorry, let's show this again. You do a section view from here. So you click on section view, and you'll see this. Wait, why is it so weird? Hold on. Okay, you click section view, and you hold control. Let's zoom in, and you fix 1 point. And now I see these two lines are like perfectly vertical right now. And then you just go along with this vertical line, and you see the little yellow symbol right there is a vertical line. That means this one's perfectly vertical. So you hit your mouse button once again, and you fix that the line's location, and you click yes, and then you have your cross-sectional view here. And hit again. Okay. And for this one, same. You want to break it, you can break it. So this one can move freely. And let's just bring this down a little. Let's bring the entire model down. Yep. Keep your drawing entirely within your page. So it somehow looks so big to me. Yeah, this one feels better. Yeah, you want to leave enough room for dimensioning. Okay, and you can see the scale is labeled right here. All right. Are there any questions so far by placing the projections and cross section? Okay. All right. So next step. The datum A. Well, this is not datum. The A right here is a cross section area. That's why it says cross section A-A, because there's two A's here. That's former cross section, and you do it through this button, section view right here, and they're gonna ask you to pick a orientation, and you hold control so you can pick the first point and then bring it down to be a vertical. The actual model right here. Yeah, is also there's a button right here, so called section view, and you can click on that and reference any datum that can form a cross-sectional view, and it give you this view. I picked the right plane in this case, so it cut it this way. If I, for example, if I choose the front plane, you're gonna cut by this direction. Yeah. All right, let's get back. Annotation, and let's just bring up all the dimensions that was created during the modeling. So pay attention, if you didn't create the enough dimension during your modeling, this won't bring it up. Then you have to define any dimension that you want it by your, like, manually. So fully define your I'll say fully define your model before you made it. All right. All right. This is kind of messy because kind of focus. Everything is on this view, and something is on this view, and just 2 dimensions on this view. And if this is the way distributed I liked, probably not. So let's clear the section. Oh, let's start again. So model items, this view, entire model, and let's show them all. All right, so we're gonna do one view by one view. So leave the dimension that we liked in this view and delete the thing we don't like. So when we go through another view, those gonna show up again, and we're gonna make the decision to keep it or leave it. So now let's rearrange the position of these dimensions. And this one looked vertically. If you want it to look in another direction, go to here. You'll click on that dimension and bring up this property table. And there's a leader at the second tab, the leaders at the second tab. And right here, either you can break line by somehow or custom text position. And you can make this horizontal. And this one is still vertical, but no underline. You can see those are underlined. So you can make this like that. And this one. Wow, they really memorize this, because when I first make the drawing, I didn't add any tags. I didn't add any taxes. And after when I finalized the drawing to make it show like this, those tags, like all around or those stuff, is all I added. And now it just, the model, it memorizes it. So, okay. So before, it doesn't even have this. So before, when you first create it, it's gonna show like this. And look at here, it's gonna be, let's drag all this away. Oh. Solidworks is smart. It just did a lot of stuff for me. So you can see the leader line right here is kind of weird, right? It's pointing at this radius, but there's another line extruded out. So why is that? You go to the leader, and you can see there are different leader styles. So here it says radius. This is diametrically, and this is another way of diameter. So when you click this, like open leader, that line disappeared. So keep it this way. It's gonna look a lot neater. Otherwise, you know, if you have lines extruding out right there, you don't know if it's part of the model or is part of your leader line. So okay, remember all the text in drawings or notes, anything must be all capitalized. All capital letters, just like Trump's tweet. Capitalize it as much as you can. So don't go lowercase. All right. So also this bring up during the annotation, this is also a center line. Let's keep it because we do have holes right here. But let's keep it short. All right, and this is also a center line, but this one not gonna mean anything. Let's get rid of that. So this one. Okay, fix your leader lines so that it won't go into the model. And this one. So this one is talking about the flat surface. So that's why it doesn't have a diameter symbol right next to it. This one is overdefined. We can get rid of that, same as this 2.5 as 2 already. And this one, okay. The reason I put this one as a reference dimension is because normally in industry, when we do a fabricated part like this, if you making a cylinder, normally we use NC pipelines. So if you go to Google and search for NC pipe schedule, these numbers are, I can make it more left. Anyway, so these numbers right here are different sizes of pipes. And the numbers of the OD and wall thickness, which gonna give you ID, right? The OD minus 2 wall thickness gonna give you ID, are fixed and defined by different schedules. So normally if you do like at home some plumbing work or something, it's gonna hurt a lot, like schedule 40 pipe or something, schedule 60 pipe. But I would say 40 and 80 are used the most. And normally 8 inches or 10 inches, like those are used a lot. That's why I put that as a reference dimension, because in this case, if we say in our bill of material saying this gonna be like ANSI 40 schedule 8 inches pipe, then we don't have to deal OD and ID because those are all fixed by the ANSI standard. That's why this one right here I put is a reference dimension. Because in build of material, we can say this one is an ANSI schedule 40 pipe, 8 inches, and length as required. Because we already defined the overall length from this top surface of plate and the bottom surface of plate and 2 plate thickness. So whatever this length is, we don't need to define it. We can just say as required. And whoever gonna do the welding, like the fabricator, they will know. All right, and this is gonna define the window, and that 1.5 will define the top window distance. Why is it doing that? This one's defined already, and this defines the whole location of the sensor. All right. So let's leave it here, but we're definitely gonna move it because right here it won't. From this picture, this hole is too small, especially after you print it. This hole can be easily missed. So later on, for small stuff, we're gonna do a detail view, just same as this one. Okay, let's move on to this. Model items, and select everything, and click yes. And here we have a whole bunch of stuff. Let's separate those first so we can define one by one. All right, let's get rid of this because this one is already covered. This one is already covered by this. See, the radius of 5.25 in diameter is 10.5. All right. And this one, 4.25, is also defined by this. All right, let's get rid of that too. So what left is 2 BC, means boat circle. because those holes are gonna for bolting. So BC is bolt circle. You're gonna see that a lot. And let's make it the same. I'll say initially you don't. So since this is not my first time doing it, right? Like when you do it first time, you're gonna find out these two stuff gonna have exactly leader line pointing at the exact location. So for example, you're gonna have a diameter of 10, two of them, and the leader lines are exactly the same. Then later on, you know, oh, it's talking about the same thing. So you're gonna delete one and just keep one. Like last night when I'm making this drawing, this one is not 10.5. So pretty much you're gonna have 5.25, and I make that 5.25 to be this 10.5. And today, because of the extraordinary memory of the Solidworks, it kind of remembers me what I did last night. For example, adding those taxes. And also they're gonna bring up the initial dimension. That's why it showed up too. That's why it has so many like overlap dimensions today. No. You're not gonna have those unless it's very obvious. For example, like this 2 diameter 10. Like for example, the most common mistake that made for beginners are if you design this drawing, for example, you design this diameter 10 in this drawing, and then later on you design another diameter 10 in this drawing because you kind of forgot, right? Or this 10 already showed up in another view. This is very common, and I won't deduct any points off because of that. But if there are two 10s right next to each other and pointing at the same thing, it just very simply means you're lazy to get rid of one, or you know, you definitely didn't see it or something. Maybe I'll deduct some points, but most likely not. But just I want you guys to spend some time on your drawing and make it as neat as you can. Yeah. Okay. So like I said, this dimension is what I made. And actually you can, if this one don't show up or this one is not showing up as the form you liked, you can just always create a smart dimension. And about this four circle right here. And for example, this one is 4.25 in radius, right? You want to make it 8.5 diameter. You come here leader, and change this from radius to diameter. And you will have this, and you change your leader line to this, and text this, and add a tax. So you can now get rid of this R because it's not a radius anymore, and simply put BC. And oh, my bad, I forgot to add this. So you can add the symbols down below. There's a diameter, so add a diametrical symbol. So these two are right now identical. But these two are gonna be different because if you click this one, it says D1 at sketch 4, right? And you click this one, the name it shows is RD2 drawing view 12. And we already explained this. This one is a driven dimension, like a weak dimension. And this one is driving dimension. Driving the model is a strong dimension. So let's get rid of this and keep this. Okay, and move the leader line out of the hole. You don't want your leader line arrow to block any hole or the content that you want to show on this drawing. Same theory on this one. Okay, so the reason I put BC right here to indicate those are both circles is because is there a tax in the center? Yeah, there's tax in the center. I'll deal with that later. The reason I put BC is because the both circles supposed to be basic dimension. Basic dimension, if you recall, oh, wow, what did I do? Sorry, I clicked something and can everybody see my screen now? Hello? Everybody see my screen okay? I think I just exited the screen sharing. Okay, now I'm back on. So basic dimension, if you refer to the angle Gd&T, okay, the angle Gd&T right here, see the 15 degree? This is basic dimension. As I explained last time, it's called theoretical. It gives a theoretical value and it's boxed. However, it's my fault. I don't know how to make basic dimension in Solidworks. I did some research last night and still couldn't do it. It requires some MBD module, and which my Solidworks doesn't have. So that's why I label those as both circle, because once you label those as both circle, even though those are just regular dimension, but the machinist can recognize it, the default tolerance won't apply on those dimensions. So they will treat it same as the basic dimension. So this is an alternative way. So if you really master of SolidWorks, know how to make basic dimension, very easy, please let me know and do it in your first project. But if you don't know, same as me, I don't know. And I researched it, couldn't find a solution, and just make this as a both circle. Okay, clear? All right, same thing to those. Let's just clean those up. So one hole right here. One hole right here. Okay, move it around because I don't want this arrow to block this hole. Okay, so this one, we can get rid of this one because look at here, what does it state? So right here it states 3/4 of hole, 10 UNC and 0.5 deep, 4 holes equal spaced, straddle center line. This pretty much covers this. Why? Is because the deep is what I manually insert. So you just come here. Initially, it was like this, has nothing, but you can like insert, like for example, this one, 0.5, and saying 4 holes equally spaced. And what else? Straddle center line. Center line symbol right here. Since we pick the ANSI standard holes and have thread on it, this should be automatically covered by that. So we can get rid of this one. This one is talking about the hole, I think is pitch diameter and the thread depth, something like that. And I'll fix the leaders. Okay. And this one has less the straddle center line because this hole's pattern is already exactly on the center line. It's not straddled. Normally, you want holes to be straddled around center line because when you're doing cross-sectional, you don't have holes on the cross-sectional drawing. It won't confuse anybody, but I just want to show different examples. One straddle, one non-straddle. All right, so the center text, that means the number of holes. I don't know why SolidWorks bring those up, but you can just delete those because we're gonna mention it. So total of 8 holes, total of 4 holes. And let's do this one. Select everything, entire model, yes, okay. So let's bring those up. Okay, have this, put us horizontal. And then clean up. Okay. Same thing on this one. The all around is what I added because I told I have 4 corners. If you don't want label all 4, then do all around. Normally nobody want to label all 4. That kind of looks really crowded. Bring this up and extend the center line a little bit. Get rid of this line. All right, and here you have a 0.75. Let's keep it and deal with the sensor holes. So sensor hole, we want to do a detail view because it's too small. We want to make it bigger. So detail view, you just draw a circle, go detail view and click somewhere around the, click somewhere on the model, and the circle gonna automatically expand and place the view somewhere you can see. And you want to change this with leader because I feel the default one is really hard to see. So please do a leader or work circle if you like. It depends on you. And this one, do a detail B. So that it won't confuse the B with some other stuff. All right, I think this is good enough. And come down here and fix this up because it says detail B, and just get rid of that. And we're gonna add something right here. Since we have 2 spots for this one, right? So instead of dimension both of the sensor spot, let's just say it down right here, 2 places, and 180 degrees apart. So they'll know exactly what to do dealing with the back surface. Okay, so now you can see this 0.75 should be really moved down here, right? So click on that, it turns yellow, right? And hold your control and just move it down. And delete the first one. You have a 0.75 here. Move it. Move it down. All right, so this hole doesn't really have a center line. And if you want to do a quick way, you can just draw a center line from here to here. So you're gonna have a very dim center line. Okay, what else we're gonna put in here? We define, oh, okay. This 1.5, right? Oh, wait, sorry, this 0.38 need to be moved down here because this one is too small. Select that and hold your control and move it to this view. So they know where exactly to drill this hole. And since this hole is located on the center line, so not necessarily tell them this hole must be on the center. Okay, also here's the hose information. and select it. Also, okay, display option. Weird. Huh. Nope, it doesn't want to come here anyway. Let's generate something else. This one, I have a leader. All right. Wait, what was that dimension again? 2 times quarter. 165. Okay. Wow. Anyway, let me see this. Now we need to find that symbol. Where is that symbol? Wow. Where's that depth symbol? No. Here. This one. Here we go. Okay. Actually, we can get rid of the 2 times since we already have stated 2 places, right? All right. Anything else? I think it's this. Nope. What's that? Is it? Oh. Not detailed. Why is So I'm trying to dimension from this edge till the vertex right here. I don't know why it doesn't allow me to select it. I better do it here. Wow, this was weird. Yeah, sometimes it's just acting up. I don't know why, but we can always sketch something. All right, let's sketch a point right on the vortex, and let's dimension this one. Since we already have a point, and here, all right, since the point is what we just sketched, and we try to dimension from the actual model to that point, so we can define whatever that could be, right? And we know the distance we set up is 0.73. From this drawing, 0.73, and we can say like this. So pretty much this is a way to fake a dimension. But sometimes you gotta use it because really, I'll say it's not worth it to waste time on something the software is acting up. Just like last night, I have no problem to dimension this 0.73, and today I can't. So I just make it. And you guys can use that as well if you feel comfortable, even though it's not a good practice. But definitely when you're trying to complete this drawing on time before deadline, you can use that. And a little explanation about this 0.73 and this 0.65. So this hole, you can see, is it's like a cone shape or something like that, because when they drill this hole, is like the drill bit is not flat at its top, and so that's why it has like a little deep right here, I'll say. So pretty much the effective length is still 0.65, but the total length is 0.73. Sometimes you want to state that, sometimes you don't. Doesn't really matter, as long as you define your hole like manufacturing method is either tapped or straight or through, something like that. All right. Anything else on this drawing? Okay, title block and Gd&T. Right. So let's do Gd&T. So under annotation, oh, the datum. Sorry, didn't define datum yet. So datum A, we want to be the center axis, because every symmetric part, you want your datum A to be the center axis, especially rotating components or rotating related components. After you define your A, you have your B right here. So B, you want something vertical. So either this one, or you can define this one as your B. Same thing, because the outer surface of the top plate is just one surface. So A and B are defined. Now let's do Gd&T. The first one, let's go with flatness. And default value from the chart for thousandths of an inch. And no reference datums at all. So you can just click OK. So you have this right here, and you can select a leader line. Right here is no leader line, but you can do this one. So you can attach it, the leader line to the surface that you want to apply the flatness. The top surface, because that was, as I mentioned at the beginning, we want a motor to sit on top. Another Gd&T, let's do the Renault. So the Renault definitely gonna have a little bit tighter clearance, but let's see what the default is. Yeah, 4,000. Okay, it's a little bit loose this time. And the tolerance, sorry, the total run-out should be reference something, for example, the center axis, right? Because it's doing rotating stuff. And this time, you don't want to put a leader line because we already have a dimension defining this hole, right? This 1.75. So you can put it right here and move it close. Attach or not, up to you. This one is fully attached, but from this drawing, it's not really attached, but everybody knows this one is going with this 1.75. Okay, let's do a circularity. The default value right here is 4,000. And no reference at all. Okay, right here. And it can go with any dimension. No. I don't want to be attached with that one because this is not a surface. This is the boat circle for these holes. What should I do to deattach it? Oh, okay. I just move it. No. Huh. Great. Let's delete it. Yeah, sometimes you don't know what to do to start over. It will save your time, actually. Wait, where has that go? Oh, right here. All right. All right, this time I'm not going to attach it. I'm just going to place it underneath. So representing this dimension is controlled by the circularity here. And one more, let's do position. So 14,000 or 20,000 normally are the default value. And primary gonna respect to A and B. Actually, it's making more sense to primary as B and secondary as A. I'll place one right here. And Control C, Control V. Copy and paste. You have another one right here. Okay, anything? Title block. So right click on the title block, edit sheet format, and then you can just double click on any box so you want to edit. So remember all capital letters, driver support. And change your draw number because normally draw number is just a number. And revision, this one's important, 0. And material, make up a material or follow the default material that you pick your part from. So you normally just gonna be stainless steel or irons or sometime aluminum bronze or something like that. If you want to go fancy, you can do that. And the default tolerance, you don't have to fill that in. And put your name and your date. Anything else? No. Wait. No, we're not gonna do that. We're not gonna do that this time. And once everything okay, just return. And let's insert a table. So search table right here, or you know where to find it. And open up the table. general table. So columns 2, row 2, that's fine. Place it anywhere, and you can modify the width first. Formatting, column width. So the first row, the first column, you can always put a quarter because those are just numbering stuff, right? Like this one, we're gonna put 1. This one, we're gonna state notes. And this one, we're gonna do as required surface finish. Like 125 is very standard. If you want to go finer, 63. If you want to go even finer, you can keep going. I don't know what the next number is. Normally 125, 63 covers a lot of stuff. Specify. So you can make this longer. Make this like that. It's all up to you. And make sure your table is not interference with any dimensions or drawing. So I think pretty much this is it, right? Anything else? All right. Okay. Yeah, the 6 is right here. A surface finish is how rough you want your defined surface. So surface finish, also known as surface texture or surface topography, is the nature of the surface that's defined by the 3 characteristics of lay, surface roughness. Where is it? So lay, surface roughness, and waveness. It compresses the small local derivations of a surface from the perfectly flat idea. Okay. So pretty much, when you see something really shiny, that means the surface finish on this thing is really fine. Something you see not that shiny, but you can tell is steel, then that means it's kind of rough surface finish. That's how I memorize it. And the finer the surface finish goes, the less friction and that kind of stuff is. So I want you guys to define a surface finish because pretty much later on all the drawings, when you guys getting a job, they want you, any machine drawing, they want you to define a surface finish. So the goal for me is telling you this is a thing, don't forget it. And it is relatively important for a job. All right, any question? I think this is about it. This is how I would do for the first project. Yeah, the smaller number, the bigger number, the opposite way, the bigger number is more rough. Small number is more fine. And the surface finish is not go by an arbitrary number. They have like a chart or something like that. Yeah, I think it refer back to the machinery handbook. Wow, those all charges. Oh, anyway. Yep. So 125 RMS means this. The totally opposite weight of the sandpaper. No problem. Oh, okay. Sorry, the last step I forgot to show you. To print. So this is a Solidworks drawing. So you'll see the format of this drawing is SLDDRY, means Solidworks drawing. You cannot turn in this to Blackboard. All right. If you're turning this to Blackboard, I'm not able to open because this one is referencing your model. All right. So what I want you to turn in is you go File, you go Print. And right here, one of the options is Microsoft Print to PDF. I want you to select this one and you go Property. Oh, sorry, not Property, Page Setup. Go Page Setup. And since we're using the A3 right here, it says A3 right here, format. And I told you A3 is B size, it's 16 by 11 inches. So it's called tabloid right here. If you go letter size, which is 8.5 by 11, choose the letter. All right, don't mess this up. Otherwise, whatever the PDF you saved, it's gonna look like either partial of your drawing, or you're gonna have a whole lot of empty spaces. So this one, if we do tabloid and say okay, and okay, and we want to save this as whatever your name is, probably project 1 or something, I'll just call it Java support 00002. And I click save, it's there. So you go this folder and you open it up, it's gonna show you like this. Get it? And you turn in this PDF. You upload this PDF to Blackboard under the project 1, which I'll create later. Don't turn in SolidWorks drawing part, okay? And just to show you guys, if I want to print this in a wrong size, if I choose this to be letter, and this okay, and I print, let's do it again. November 1st, midnight. Okay, let's go back. Open up this. Look, this is the wrong size, so it only shows partial of the drawing. The majority of information is not covered here. If I do receive something like this, you know what's gonna happen, right? So be careful with your size, be careful with your format, and I mean the sheet format, and also be careful with your drawing format. Turning PDF, not the SolidWorks drawing file. Okay? All right, any question? Use B as the leading reference point of the holes. Because B is one of the edge that the hole gonna be placed on. Right? Yeah, for example, like if you have a square table and you're gonna have holes on the table, the only thing you can reference with is 2 edges of the table, right? Since this one's circular, so you're definitely gonna use the OD of the plate as a reference, and also the center axis. Oh, actually, you know what? There's one more Gd&T gonna suit perfectly in this drawing, which is parallel. you're gonna have parallel off this surface to that surface. Yeah, this one is actually better than the total rent out here. The total rent out right here is what I made up, because normally it shouldn't be right here. I just made it up for this case, and the parallel for the top surface and bottom surface is perfect example right here. All right, for the people who doesn't have any question, you're free to go. So this is all I want to cover about the project one, and this is what I expect from you guys, a drawing like this. Project gonna be due on November 1st, midnight. No problem. Thank you guys. Thank you for attending, and I look forward to your first project. Yeah, I can upload the drawing. I'll upload the PDF. Oh, which part do I understand the homework 3? The instruction or the content? Both? So pretty much homework 3 gave you 3 projections, right? And you use the, sorry. Homework 3 gave you 3 projections for 4 different models, and you use that projection to generate a model in Solidworks, and then take a screenshot of your model for all 4 of them, and then submit it to Blackboard. You know, screenshot can be copy and paste in a Word document or something like that. And Windows has a built-in snipping tool. Use this one to take your screenshot. Like I want to take a screenshot of this drawing is right here. And you know, you copy paste into a Word. And you need 4 of those.
Sorry, it's just easier to talk without having to type. So is it 4 models or is it 3 pictures that represent 1 model?
What?
Is it 4 SolidWorks drawings or is it, because on the homework, it's like 4 different sketches.
Homework 3 is posted. Please create 4 models based on its projection drawings and submit the SolidWorks screenshot for an asymmetric view of each model to Blackboard. And when we look at assignments, homework 3, this is one model, this is another model, and this is your 3rd model, and this is your 4th model.
Okay. So as long as we like make sure the angles match, like the view angles match those drawings, and we're okay.
Yeah.
All right. Thank you.
It's kind of weird, man. Just, yeah. Have you done homework 2? Because this is completely opposite as your homework 2. So homework 2, you have model, right? And you need to create projection drawings. And this time, I give you projection drawings. Is your turn to create a model.
Yeah,
so,
I did homework too.
Yeah, so it's like complete opposite.
Okay.
Cool.
Sorry, this class confuses me a little bit.
No problem. Just ask. And if you want me to do a demo, I can do a demo for you.
That's okay. Thank you, though.
Yeah. Anybody else? If there's no more question, I will end this meeting, and anything happen, just ask me through email. Alrighty. What do you mean start from the top or start from the front? I don't get it. You mean start sketching from top view or? Doesn't matter. It depends on your understanding. Like for example, the first one, I probably start from this one because this one is just a square, right? And then depends on how you understand this model, and or sorry, I'll probably start with this drawing. So I draw like this, and then I extrude it, and then I cut this corner. So this is what I do. Gonna do the first one, and second one I will start with this one. So draw two circles, and link the top, link the middle, and get rid of the actual circle stuff, and then extrude, and you got this one. So third one, start with this one, draw this shape, draw 3 holes, and then just do a simple extrude, done. And for this one, you start from here, draw the circle, make the keyway, and extrude the base first, and draw the second circle, extrude the top portion. Is it clear? Hello. Okay. Thank you very much. Any question, just email me. And if you want me to do a demo, I'll do a demo for you. Okay. Alrighty. Have a good night, man.